All right, so here are some ionic formulas or ionic chemicals I would like to find the formula for. And you might say, well, how do I even know these are ionic formulas? And generally, the best way to realize this is that they usually consist of a metal and a nonmetal. So here we have calcium is a metal, and we know that because it's on the left side of the staircase. And chloride is another kind of way of saying chlorine, and that's a nonmetal. Lithium's a metal, sulfur is a nonmetal. Gallium's a metal, oxide refers to oxygen, that's a nonmetal. So a lot of times you'll be told it's an ionic formula, but in case you weren't, that's sort of how to figure it out. So how do we go about this? Well, we figure out what the atoms are. So in this case, I have calcium and I have chlorine. That's what the chloride is. And before I can do anything, I need to determine their charge. So if you're not sure how to do that, go back to step 1 of this video and tells you how to figure out the charges. But calcium has a charge of +2, and chlorine has a charge of -1. Going along here, lithium has a charge of +1, sulfur has a charge of -2. Gallium has a charge of +3, oxygen has a charge of -2, aluminum has a charge of +3, phosphide refers to phosphorus, has a charge of -3. Again, if you can't do that, go back, watch that, figure out how to do that. So now, knowing these charges, what's next? The key to these ionic formulas is they need to balance. We need charges to equal 0. Put another way, if calcium and chlorine met up, which one of them is currently stronger? Calcium has more than chlorine. 2 is bigger than 1. So this is not a balanced relationship. So what has to happen here? Well, what has to happen is another chlorine atom with a charge has to come into the picture to balance out the calcium. So you just add to the side that has less charge until they're equal. So now, calcium has a +2 charge, and the chlorines together have a -2 charge. So this is balanced. So then to write the formula, you just write Ca, and since there's only one of them, we just leave it as Ca. Then we write Cl, and there are 2 of them, so we write Cl2. And that is what we do for an ionic formula. So this tells me there's 1 calcium and 2 chlorines. We never write the charges in the formula. It's understood when we look at it that calcium's +2 and chlorines are each -1. Do not ever write the charges in the formula when you're done. All right, here, lithium and sulfur. Lithium has a +1 charge, and sulfur has a -2 charge. So sulfur is sort of winning this fight. And so in order to even things up, another lithium has to come along to balance it. Okay, 2 lithiums, +1, 1 sulfur of -2, they cancel each other out evenly. So I say, okay, Li, there were 2 of them, so I'm going to write Li with a small 2. There was only 1 sulfur, so I'm just going to write Li2S. And that is the ionic formula for lithium sulfide. All right, now this one's a little trickier. Gallium and oxygen. Say, okay, who's winning? Right now, gallium clearly has the upper hand. Oxygen's 2, so we need another oxygen. So we say, okay, we need another O with a -2 charge. We can't just add an O with a 1- charge. It doesn't really exist in very many forms, so we have to add another 2-. But when we do that, now it's unbalanced again. Now there's more oxygen charge than gallium. So what happens? Well, we got to add to the gallium side. So if I add another gallium, now gallium's +6, but now oxygen's unbalanced again. So we go back to oxygen, and now it's even. 6+ and 6-, they're equal. So I can write Ga2O3, and that's the formula there. This last one's easy. Look, they're already balanced. 3+, 3-. All I have to do is write that there's 1 of each, and that is the formula. Sometimes that's all you have to do. Nice and easy. But again, never write the charges in the final formula. Make sure they add up to 0, the total charges when you're done, or make sure they're equal on each side. And that is ionic formulas, essentially. That's all you really need to do. Now, you may not have to draw this out. I like to do it, especially if you're new to it. But after a while, you can kind of just come up with these answers in your head. But don't be afraid to draw it out if you need to. I think visually it makes a lot more sense when you see, oh, okay, +6 and -6, they balance each other out. So that is sort of basic ionic formulas. There are some that are a little more challenging, which we'll get to in the next video. So until next time, I am Derek Genova. Have a delightful day.